guys, I am teacher Carla, and for today, we will be learning about operations on sets using Venn diagram. Keep your math notebook with you and be sure to take down notes.
Second part of Unit 1, Language of Collections. Today we will be still learning about sets and subsets, specifically, the different operations of sets using Venn diagram. To understand better our topic for today, take note of the following key terms: set, subset, elements, union, intersection, diagram. In this chapter, you will define and describe the different operations on sets, identify relationship of sets through Venn diagram. In this chapter, you will perform fundamental operations on sets, use Venn diagram to represent the operations of sets, determine the proper placement of the elements of sets in Venn diagram, list elements of sets using roster, verbal, and set builder notation form. It is important for us to know about sets on Venn diagram because we often compare two or more groups in real life. Learning about sets and operations of sets through Venn diagram will help or train us to solve correctly word problems. What is Venn diagram? It is used to represent relationship between collections of objects or sets. Venn diagram was developed by John Venn and named it after himself. He was an English mathematician, philosopher, and logician. Study the different parts of Venn diagram on sets through Figure 1.3. The rectangle is named as set U for universal set. All elements found inside the rectangle are all elements of set U. Two overlapping circles are the representation of two sets named set A and set B. We write the intersection of two sets on the center part. The remaining elements of A which are not elements of B are written on the part of circle A, while we write elements of B which are not elements of A on the part of circle B without touching the intersection.
Hello everyone, this is Dr. Esperanza at kung bago kayo sa channel ko, please subscribe para mas marami na kayong students na matulungan ko. And for today, magsasagot naman tayo ng mga problems involving Venn diagrams or set operations. Let's say meron tayong union sets na kung saan meron tayong A, B, C, 4, 5, 6 as an element of the union set U. Pwede natin siyang ilagay sa isang diagram na rectangular yung shape at ito yung laman ng ating set U, which is A, B, C, and 4, 5, 6. Now, kung meron tayong set A na A, 6, at saka C, na kung saan yung A or set A ay subset ng ating union set na U, pwede din natin siyang gawa ng diagram na kung saan i-enclose natin sa isang circle si set A na subset ng union set na U at yung mga values na nasa union set or elements ng U set na wala sa set A ay nasa labas naman ng ating circle A. So ito yung isa sa mga pamamaraan na kung saan pwede nating ilagay sa diagram yung ating set at ang subset sa isang diagram na tinatawag din nating Venn diagram. So ito yung mga Venn diagrams na gagamitin natin today. Meron tayong disjoint sets at meron tayong proper subsets. Yung unang Venn diagram na nakikita nyo, yung disjoint set, yan yung sa ating isang union set, yung subset A at subset B ay magkahiwalay or wala silang elements na common sa isa't isa. At meron naman tayong proper subsets dun sa diagram 2 na kung saan yung lahat ng elements na nasa set B or set A ay subset ng set B na kung saan naka-enclose din siya sa isang union set. So ito yung Venn diagram na tinatawag at kailangan matutunan natin kung paano mag-identify at magbasa ng Venn diagram para makapagsagot tayo ng mga tanong about sa subset at union ng mga sets. So let's say meron tayong Venn diagram at ang nakikita nyo ngayon ay isang Venn diagram na kung saan meron tayong subset A, subset B, at meron din tayong subset na 1, 2, 3, and 4. So kung i-analyze natin yung subset na yan, makukuha natin yung ibang mga subsets sa isang union set sa pamamagitan lang ng pagtingin sa diagram. So let's say, hanapin natin ang lahat ng elements ng union set or yung set U. So yun yung mga elements na nandoon sa loob ng set U. At yun yung A, B, C sa group 1. at yung D sa group 2, at yung E sa group 3. At meron tayo sa labas ng dalawang circles na yan na F and G na kabilang din sa set U. So ang ating set U or union set would be all the elements that you can find in and outside of set A and set B. Now, kung kukunin naman natin yung elements ng subset B, yun yung mga element na nakapaloob sa circle na B, na kung saan nandun yung group 2 at group 3. So, ibig sabihin nun, ang elements ng subset B would be D and E. So, yan yung pag-identify natin ng union set at ng mga subset sa loob ng union set. Now, kung kukunin naman natin yung set of elements in U sa loob daw ng union set but not in B, it means lahat ng elements na nakikita nyo sa loob ng rectangle pero tatanggalin nyo yung elements ng letter B which is yung D and E ay kabilang dito sa set na hinahanap natin sa number 3. So, therefore, yung ating set na kung saan meron tayong lahat ng elements ng U but not the set or elements ng B, yun yung A, B, C, at saka F and G. So, yan yung pagkuha or pagbasa ng Venn diagram sa isang union set. Now, ang susunod naman nating kukunin ay yung complement ng isang set. Ang complement ng isang set, yun yung mga subset na hindi mo makukuha doon sa given subset. So, for example, meron tayong A prime na kung saan yun yung symbol na ginagamit natin sa complement ng set A. Ang laman daw nito ay yung mga X such that X is an element sa union at X ay hindi element ng subset A. So yun yung A complement na tinatawag. So let's say meron tayong union set na merong 1, 2, 3, 4, 5, 6, 7, 8, 9. At yung ating subset A na subset ng set U ay 1, 3, 4, 7. So ibig sabihin kung kukunin natin yung complement ng A which is denoted by A prime or yung apostrophe na nakikita nyo, yun yung mga elements na hindi matatagpuan sa subset A na nasa loob ng union set na U. So ibig sabihin nun, yung 2, 5, 6, 8, and 9 na nasa U pero wala sa A, yun yung tinatawag nating complement ng A. So yan yung pagkuha ng complement at kung babase natin siya sa isang Venn diagram, pwede nating makita na yung ating union set ay merong subset A which is yung 1, 3, 4, 7 at nasa labas niya yung complement ng A which is yung 2, 5, 6, 8, 9. So ito yung paraan ng kung saan pwede nating i-visualize sa isang Venn diagram yung U or union set at yung subset na A at yung complement naman ng A. So, meron tayong tinatawag din na intersection of sets or yung ating AND operation na kung saan yung X or yung A intersection B ay composed of two subsets which is A and B na kung saan yung X ay any element ng set A at yung X din ay distinct element din ng set B. So ito yung tinatawag nating intersection or minsan tinatawag din nating AND operation. So let's say meron tayong dalawang subsets, set A at saka set B. Sa set A, meron tayong 7, 8, 9, 10, and 11. Sa set B, meron tayong 6, 8, 10, and 12. Yung A union B, yun yung mga distinct element ng A and B na makikita natin sa parehas na subsets. So in this case, yung 8 at saka yung 10 na meron tayo sa subset A at sa subset B would be the intersection of A and B kasi yun yung common na element na makukuha natin sa set A at saka sa set B. So kung kukunin natin yung Venn diagram nitong set na ito, yung ating union set, lahat ng numbers natin is nasa subset A at sa subset B at makikita nyo na sa bilog ng A, meron tayong 7, 9, 11, 8, and 10 at sa grupo naman ng B, meron din tayong 8, 6, 10, and 12. Pero yung sa gitna, yun yung tinatawag nating intersection or yung end operation ng ating union ng intersection ng sets. So 8 and 10 ang intersection ng set A and set B sa loob ng isang union set. Kung meron tayong intersection of sets, meron din tayong tinatawag na union of sets. Yun yung symbol na parang letter U. So, ito yung union sets na tinatawag or yung sinasabing OR operation. So, kung meron tayong A, union B, ibig sabihin nun yung X na nasa element ng AB such that yung X ay element ng A or yung X ay element din ng B. So, sa ganitong pamamaraan, halimbawa, meron tayong dalawang subsets. Yung A is 7, 8, 9, 10, 11 at yung B ay 6, 8, 10, and 12. Yung A, union B, ibig sabihin nun, yung anong mga elements na makikita mo sa A at kung ano yung mga elements na makikita mo ng B, pagsasamahin mo sila doon sa union sets. So, ibig sabihin nito, makikita nyo na meron tayong number 6, 7, 8, 9, 10, 11, and 12 sa set A and sa set B at yan yung tinatawag natin na union sets. So, kung meron tayong A, union B, yung lahat ng mga elements na makikita natin sa subset na distinct, yun yung ating union of the two sets, which is A union B. At kung titingnan natin siya sa ating Venn diagram, yung A union B would be everything na makikita nyo doon sa element ng A and B, which is 7, 9, 11, exclusive sa A, 6 and 12, which is exclusive sa B, at yung 8 and 10, which is yung intersection ng A and B, ay kasama pa rin natin doon sa A union B. So, pagsama-sama na yung mga elements natin sa dalawang subset, as long as distinct yun yung ating A union B. So, ang ating gagawin sa susunod naman ay kung paano naman natin kukunin yung mga operations involving a given union set. So, let's say meron tayong union set. So, andito lahat, yung 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. At meron tayong subset A at meron tayong subset B. So, gagamitan natin siya ng mga mathematical symbol. At kung alam niyo yung mga symbols na nabanggit natin sa ngayon tulad ng apostrophe, which is yung complement ng subset, yung intersection, at saka yung union ng set, pagsasama-samahin natin siya sa isang problem para makuha natin yung distinct element na hinahanap natin sa isang subset. So, ito yung letter A. Meron tayong complement ng union ng A and B. At yung letter B naman, kukunin natin yung complement ng A, intersection ng complement ng B. So, let's start with the first one. So, kukunin naman natin ngayon yung complement ng union ng A and B. So, makikita nyo yung ating U set ay merong numbers 1 to 10 at yung subset A ay 1, 3, 7, 9 at subset B ay 3, 7, 8, and 10. So, kung kukunin natin yung A union B, so para siyang order of operation. So, kukunin natin yung operation sa loob going out. So, kukunin muna natin yung A union B. So, ang A union B natin would be the distinct element na meron tayo sa A and B. At yun yung 1, 3, 7, 9, 8, and 10. Kasi yung 3 and 7 na nasa B, nabanggit na yun sa A, which is 3 and 7 din. So, kukunin lang natin yung lahat ng distinct element ng parehas na subset. So, ang A union B natin is 1, 3, 7, 8, 9, 10. At ang kukunin natin is yung complement nung union na yon. So, ibig sabihin, kukunin natin yung lahat ng natitirang element sa U na hindi nabanggit sa A union B. At ito yung ating U set or yung union set at tatanggalin natin dito yung 1, 3, 7, 8, 9, and 10 at yun yung magiging complement ng A union B. So kapag tinanggal natin yung mga nabanggit, ang matitira na lang is 2, 4, 5, and 6. So ang ating complement ng union ng A and B would be 2, 4, 5, and 6. So, ito yung isa sa mga operation na pwede natin gawin sa set operation kapag alam natin yung mga symbols na ginagamit natin. Now, yung letter B, hahanapin naman natin yung intersection ng complement ng A at ng complement ng B. So, tulad ng ginawa natin, iisa-isahin natin yung ating mga subsets. Starting with complement ng A. So yung A natin is 1, 3, 7, 9. At kung kukunin natin yung complement ng A from the union set, so ibig sabihin, hindi natin i-include si 1, 3, 7, 9. At yung matitira na lang, yun yung ating mga complement, which is 2, 4, 5, 6, 8, and 10. So yung 2, 4, 5, 6, 8, and 10 will be the complement of B. At kukunin naman natin ngayon is yung complement ng, yung complement ng A. And then kukunin naman natin ngayon is yung complement ng B. So yung B, meron tayong 3, 7, 8, and 10. At kung sa union set, tatanggalin natin si 3, 7, 8, and 10. Ang matitira na lang sa atin would be 1, 2, 4, 5, 6, and 9. So, yan yung complement naman ng ating set B. Yan yung complement ng set B. At since kailangan natin kunin yung intersection niya, so ibig sabihin, kung ano yung distinct element ng complement ng A at distinct element ng complement ng B na parehas doon sa ating dalawang subsets, yun yung kukunin natin. At ang mga distinct na yan, or distinct numbers na yan, ay yung mga numbers na 2, 4, 5, and 6. So, yan yung mga distinct numbers na meron sa A complement at saka sa B complement. At yun yung kukunin nating intersection ng A complement intersection ng B complement, which is 2, 4, 5, and 6. So, yan yung pagkuha or paggamit ng mga iba't ibang operations sa isang subset given the union set at saka ng Venn diagram.
Operations on sets using Venn diagram. 1. Union of sets is a set consisting of all elements which belong to either A or B or both. Refer to figure 1.5. All elements which are written on small letters, on the shaded part of the diagram are the elements of A union B or union set. Therefore, A union B consists of elements of A, B, C, D, E, F, G, and H. As you will see, I and J are written outside the circle but inside the rectangle. They are not included in the union set of A and B because those are neither elements of A nor B. 2. Intersections of sets. It is a set containing all common elements of the two sets, A and B. Refer to figure 1.6. Elements of A that are also elements of B are written on the middle part of the diagram where we place similarities. All elements on the shaded part are the elements of A intersection B. Therefore, A intersection B consists of elements D and E. 3.1 Difference of sets. The set of elements which belong to A but which does not belongs to B. Refer to figure 1.7. Elements of A that are not elements of B is listed on the shaded part of the diagram. Therefore, A difference of B contains elements of A, B, and C. 3.2 Difference of sets. The set of elements which belongs to B but which does not belongs to A. Refer to figure 1.8. This time we are locating elements of B that are not elements of A. Part of circle B is the shaded part but not the whole circle B. Therefore, B difference of A is a set containing elements of F, G, and H. 4.1 Complement of sets. The set consisting of all elements of the universal set which are not elements of A. Refer to figure 1.9. The shaded part of the diagram shows all the elements of universal set when elements of set A is subtracted from it. Therefore, A complement is a set containing elements of F, G, H, I, and J. 4.2 Complement of sets. The set consisting of all element of the universal set which are not elements of B. Refer to figure 1.10. The shaded part of the diagram shows all the elements of universal set when elements of set B is subtracted from it. Therefore, B complement is a set containing elements of A, B, C, I, and J. 4.3 Complement of sets. The set consisting of all element of the universal set which are not elements of A union B complement. Refer to figure 1.11. The shaded part of the diagram shows all the elements of universal set when elements of A union B is subtracted from it. Therefore, A union B complement is a set containing elements of I and J. 4.4 Complement of sets. The set consisting of all element of the universal set which are not elements of A intersection B complement. Refer to figure 1.12. The shaded part of the diagram shows all the elements of universal set when elements of A intersection B is subtracted from it. Therefore, A intersection B complement contains elements of D and E.
This video is going to be about set operations and Venn diagrams. So I'm going to start with the intersections of sets. Let's say I've got two sets. Set A contains the numbers 1, 2, 3, and 4. And set B contains the numbers 3, 4, 5, and 6. Well, the intersection of two sets is the intersection of two sets is the set that contains only the elements that are in both of the sets. So I can write the intersection A and then a kind of an upside down U for intersection and B. I can read this as A intersect B, or the intersection of A and B. And that's going to equal, well, let's see what elements are in both sets. Set A is 1, 2, 3, and 4. Set B is 3, 4, 5, and 6. It's only the 3 and the 4 that are in both sets. So A intersect B is going to be the set containing 3 and 4. Now, I can show this graphically, or I can show the idea of intersections graphically with a Venn diagram. So I'm going to start the Venn diagram by drawing a rectangle, which will represent the universe that I'm dealing with. Maybe I'm dealing with all integers. And then I'll draw two circles. I'm going to have these circles overlap. One circle will be set A, and the other circle will be set B. Now, since an intersection is only the elements that are in both sets, it's only going to be the area where I have an overlap that I have my intersection. So the intersection is that overlapping area. If I had two circles that didn't overlap at all, then there would be no intersection. So the intersection of those two sets would be an empty set. Okay? If they overlap, it's the area where they overlap. If they don't overlap, then the intersection is just an empty set. So let's compare that with the union of two sets. So once again, I've got these two sets, A and B. A is 1, 2, 3, 4, 1, 2, 3, and 4. And B is 3, 4, 5, and 6. Now the union of two sets is the set that contains any element which is either in set A or in set B or in both of the sets, but it doesn't have to be in both of the sets. So I write that as A, and then the union sign, which is a U, and a B. So this is A union B, or the union of A and B. And that's going to equal everything in set A as well as everything in set B. I'm not going to duplicate anything. So I'll have 1, 2, 3, 4. That's all out of set A. Set B has a 3 and a 4, but I've already written them, as well as 5 and 6. Okay, so unions are elements that are in either of the two sets, or they could be in both of them. Let's show that graphically with a Venn diagram. So once again, I've got this rectangle, which stands for my universe, and I'll draw two overlapping circles, and I want everything that's in set A, so I'll shade in that circle that's for set A. And I also want all the things that are in set B, so I'll shade in set B. So what I've got is everything in set A, everything in set B, that includes the area where they overlap. If the two sets didn't overlap, I would just have two circles, and I would shade in both of the circles. Okay, so they don't have to overlap. So compare these two things. The intersections of sets, that's the place where the two sets overlap. If there is no overlap, the intersection is an empty set. The union of sets is anything that's either in set A or in set B or in both of them. Okay? Now, let's go on to set complements. I talked about this a little bit in a different video. Let's review this. So if I have a universal set, let's say my universal set is going to consist of the numbers from 1 to 10. And then I have set A. Set A is going to consist of 2, 4, 6, 8, and 10, so just the even numbers. And if I want the complement of set A, I'll write an A with a bar over it, and I'm going to get all of the elements that are in the universal set that are not in set A. So that looks like I'm going to have just the odd numbers, 1, 3, 5, 7, and 9. Okay, so the complement of a set is the elements that are in the universal set but not in the set that we're taking the complement of. To show that graphically with a Venn diagram, so here's the rectangle for my universe. I'm just going to draw a circle. That circle will represent A. And the complement of A would be everything that's in the universe and outside of the circle. So basically I'm shading in all of the areas that are not in the circle. Okay, so that's a set complement. Now we also have something called a relative complement. The relative complement works like this. Once again, I've got set A. Set A is 1, 2, 3, 4, and 5. And set B is 4, 5, 6, and 7. Well, if I want the elements that are in set A but are not in set B, I can write that as an A and a minus sign and a B. And let's see what that's going to be. So I'm going to take all the elements in A, 1, 2, 3, 4, and 5, but I don't want any of the ones that are in B, 4, 5, 6, and 7. So since 4 and 5 are in set B, I'm not going to want them. So I'll just have 1, 2, and 3. And this can be read as the relative complement of B in A. Or you maybe just want to say set A without the elements that are in set B, which is what I have here. I had all of set A except for the elements that were in set B. So let's see what that looks like as a Venn diagram. So here's my universal set. I've got two overlapping circles, set A and set B. And what I'm going to want is A without the elements that are in B. So that means I'm going to shade in only that portion of A which does not overlap with B. Okay, so this is an A, a minus sign, and a B. Some people will say that's A minus B. Technically, that's wrong. Officially, you should be saying the relative complement of B in A. As long as you know what to do when you see this, the A minus the B, and you're dealing with sets, you'll be fine. What you're doing is you're taking all of set A except for the elements that were in set B. Okay? So that's relative complements, set complements, intersections, and unions. I'm going to do another video where I show how to work with these ideas in a more complicated manner. Okay? But that's it for this one. Take care. I'll see you next time.
We've learned that the different operations on set, which is union, intersection, complement, and difference, can be solved more efficiently using Venn diagram, wherein on the diagram, the elements on the shaded part are the elements of the set being asked. Now proceed to the next slide for your activity.